I noticed the top was not showing, so you have it, right? For us to begin our next case. Good. So we look at case 2 now. For our case 2, if z is a function of x and y, but x is a function of s and t, and y is also a function of s and t. Then we replace x and y by their respective functions of x and t. Then z will become a function of two variables, x and t. So we can now find the rate of change of z with respect to only x, s. That is the partial differential of z with respect to s. And this is given by, first we differentiate z partially with respect to x and differentiate x partially with respect to s, plus then we differentiate z partially with respect to y and differentiate y partially with respect to s. Next, we also be asked to find del z del t, that is the rate of change of z with respect to t as we see s as a constant. Okay, now this is also given by del z del s. We differentiate z partially with respect to x and differentiate x partially with respect to t, plus differentiate z partially with respect to y and differentiate y partially with respect to t. Once you get a formula, you are fine. All we need is to go and look for the respective components. Del z, del x, del s, del x, s, del x, del x, plus we look for this, we look for that. This, that, this, that. We replace them where they're supposed to be, and we are cool. So we take an example. If z is equal to e to the power 2r sine 3 theta, but r is a function of st minus t squared. You see? No. Okay. Okay, let me try. S, the square root of s squared plus t squared. Here we are required to find del z, del s, and del z, del y. Here del z, del x is given by, we differentiate z with respect to R and differentiate R with respect to x, plus differentiate z with respect to theta and differentiate theta with respect to s. This is actually del z del t. We differentiate z with respect to R, differentiate R with respect to t, plus differentiate z with respect to theta and differentiate theta with respect to t. So we compute the differentials there, right? I hope you can see. Del z del R will be equal to 2e 2r sine 3 theta. And del z del theta is equal to 3e 2r cos 3 theta. As I said, if you don't get the differentiation, you can call me and we'll go through. Next, we need del R del T and del R del, let's go S first. Here S and T. If I differentiate this here with respect to S, then I'll get T. If I differentiate that with respect to T, then I'm going to get S minus 2T. I just hope I can clear this part. Next, I differentiate theta. I look for del theta del S. And this is the same as S squared plus T squared all to the power half. Okay. Baba. It's me then, why? Baby, just like why? That's it. Okay. Right. Nice one. Now, we can write this like that. Okay. What we do is that we differentiate with respect to S. With respect to S, half will come forward, and S squared plus T squared all to the power minus half. And we differentiate what is inside with respect to S, and I get 2S. Next, the theta del T, S half S squared plus T squared times 2T. This is the power minus half. Of course, take one out of the power. Next, we replace them where they are supposed to be. And we are fine. Right? And we are fine. Let me do it down here. I have to clean some parts, right? So let me begin the original one. Bear in mind that we say that del z del s is equal to del z del r dr del r del s plus del z del theta d theta del theta del s. Okay, this is what I'm going to write here. So I write del z del s is equal to del z del r is 2e 2r sine theta multiplying sine 3 theta multiplying del z multiplying del r del s. Now del r del s, what do we get? This t plus del z del theta, which gave us 3e 2r cos 3 theta times del theta del s, and that gives me, now this 2 will cancel this 2, so eventually I get s over the square root of s squared plus t squared. We have that. Okay, now we can go ahead and simplify. We can simplify, right? And we can replace r and theta, coming r and theta by something. You're meeting?
No.
You can stay. Okay. We can go and replace the respective values of theta and r in terms of s and t into the function. So you please solve del z del t, find del z del t, and comment and tell me your answer. Okay.